All right, this is the second video in section 5.4. We talked about in the last video perfect squares, where if we have a trinomial, a polynomial with three terms, sometimes we can factor it into two binomials that are the exact same thing, and we can write them as quantity squared. Let's practice a few more of those. If you look at example number 1, always follow your 7 steps, so make sure it's in order, look for a GCF, and if there's three terms, let's try to basic factor it or do bottoms up if there's a number in front that we can't GCF out. Look at A. It's in order. There's no GCF. So let's try to basic factor it. What numbers multiply to 4 that when you add them together, you also get 4? Hopefully you said 2 and 2. And since they're the exact same thing, this is a perfect square, and we can actually write it as x plus 2 squared, since there's two x plus 2 terms. All right, look at B. Is it in order? Ooh, hopefully you caught that and you wrote it in order first without trying to factor it into something else. If I put it in order, you would have a t squared minus 14t plus 49. And now that it's in order, it doesn't look like there's a GCF and there's three terms, so let's try to basic factor it. What numbers multiply to positive 49 that when you add them together, you get negative 14? Positive 49, add to negative 14, you should have said negative 7 and negative 7, which happens to be another perfect square, so we could say t minus 7 quantity squared. All right, look at C. What do you notice first? Yeah, hopefully you put it in order with the x squared first, then the negative 20x, then the positive 100. Let's try to factor it. There is no GCF and there's three terms, so it looks like this is a basic factor. What numbers multiply to positive 100 that add to negative 20? Hopefully you said negative 10 and negative 10, and since that's a perfect square, we could say x minus 10 quantity squared. Now, this is still a correct answer. Just make sure that you're familiar with both ways if they want you to write it as a perfect square. All right, let's do a few more that get a little more complicated. Look at example number 2 with me. It asks us to factor, so we're still going to follow those same 7 steps every single time. So number 1, is it in order? Well, this first one looks a little bit weird because it has a couple different variables in it. So if it's easy to tell if it's in order, then make sure you put it in order. If you can't really tell, then hopefully it's good to go and we don't have to rearrange things. Second thing, does it have a GCF? Is there a number that I can divide into 4, 12, and 9? Can I take a t out of everybody? And can I take a p out of everybody? I don't think any of those are true, so it doesn't look like there's a GCF. I notice that there are 1, 2, 3 terms in this problem, so to me this looks like either a basic factor or a bottoms up. In this case, because there's a number in front that's not a 1, then this looks like a bottoms up problem. Do you remember the steps for bottoms up? Do you remember my friend doesn't read books? All right, let's do it. I'm going to multiply. I'm going to take the 4 and multiply it by the 9. That leaves me with a p squared minus 12pt plus 36t squared. Now I'm going to factor. What numbers multiply to 36 that when I add them together, I get negative 12? Did you say negative 6 and negative 6? Now I'm going to split up the p's, one in the first one in the second parentheses. And then the only difference on this one is we have that extra variable in the back, so I'm going to put a t in the back of each one of those parentheses. So when I FOIL it out, I end up getting the p squared, and I end up getting the t squared, and then the middle terms actually have both the p and the t in it. All right, be careful, we're not done yet. We still have to divide, reduce, and bottoms up. So let's go back and divide by 4. Let's reduce, and then let's bring those bottoms up. If you notice that both of my terms happen to be the same exact thing, you should end up with a 2p minus 3t and another 2p minus 3t. So we could actually write that as a 2p minus 3t squared. That's a perfect square. It just happens to have a little bit of a bottoms up in there too. All right, pause the video and try B by yourself and see if you can get the correct answer. All right, did you put it in order? Did you look for a GCF? Oh, I hope so. There is a GCF, and remember if that leading coefficient is negative, we want to factor out a negative GCF. So I actually factored out a negative 3 and an m. When I factored out a negative 3 and an m, I had a leftover polynomial of 25m squared plus 20m plus 4. There is no more GCF, and there's 3 terms left. So let's see if we can still factor it, because we don't want to stop at GCF if we can factor more. It looks like there's 3 terms and a number in front, so we're going to do bottoms up again. Here we go. Let's multiply. Let's factor. So numbers that multiply to 100 that add to 20. I got 10 and 10. Don't forget to go back and divide by what you multiplied by in the first place, so that was 25. Let's reduce. 5 goes into both of those. 5 goes into 10 twice, and 5 goes into 25 5 times. I actually happen to notice that they're the same exact binomial, so I can bring my bottoms up and just write it as one binomial that's squared. It's a perfect square. Don't forget about your GCF in the front, the negative 3m, so you should have a negative 3m, and then you should have a 5m plus 2, that whole thing squared, because there's 2 of the exact same thing. All right, keep practicing your factoring. We'll talk about difference of squares in the next video.